You think you understand time, you glance at your watch, you feel the weight of years pressing on your shoulders. You remember what you ate for breakfast, and you make plans for next Tuesday. Time seems obvious, doesn't it? It seems like the most natural, most fundamental thing in the world, the one thing you can count on. But that's not time. That's just a sensation, a biological trick your nervous system plays on you. Most people carry around this poetic notion that time is a river. You picture it flowing, sweeping you along from the misty past through the razor edge of the present and into the unknown future. You imagine it moves. You feel it pushing you forward. But here's the problem with that beautiful, romantic image. If time is a river, answer me this. How fast does the river flow? Think about it. 1 second per second. That's the only answer you can give, and that's meaningless. That's circular. That's like saying a table is 1 table long or a stone weighs 1 stone, but tells you absolutely nothing about the actual nature of reality. The truth is much stranger, much more mechanical, and honestly a lot less poetic than a flowing stream. Time doesn't flow. Time doesn't push you anywhere. And if you think you have a good grip on how time works just because you can count seconds in your head or feel yourself getting older, you're in for a very rude awakening. Let's start with what goes on inside your skull, because that's where all the confusion begins. You think your internal clock is a reliable instrument, a precision device. It isn't. It's a chaotic mess of translation schemes and biological shortcuts. Consider a simple experiment. Close your eyes and try to count to 60 seconds in your head. Just sit there quietly and count 1, 2, 3. You think you're tracking time, measuring it, keeping pace with the universe. But what you're really doing is running a very specific, very personal program that exists nowhere else in the cosmos. Some of you, when you count, you hear a voice in your head. You're literally speaking to yourself, sub-vocalizing the numbers 1, 2, 3. The voice drones on. If someone interrupts you and asks you to speak out loud, to say actual words, you lose your count immediately. The machine jams, the program crashes, you have to start over. But others, and this is where it gets truly interesting, don't hear a voice at all. They see images. They might visualize a tape measure with numbers on it, clicking past like a ticker tape in an old news office. Click, 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 7, 8, 9. If you use that visual tape measure system, you can actually read a newspaper while you count. You can scan a grocery list or sort through your mail. You can organize your socks, examine patterns in the carpet, weaving, and still keep that mental tape measure clicking along perfectly. The visual circuit and the verbal circuit are separate. You're running 2 programs at once. But the person who counts with a voice, they can't read a single word without losing track of the time. The circuits collide. The programs interfere with each other. This tells us something absolutely fundamental about what we call time. What you experience as the passage of time, what you feel in your bones as real, is just a mental construct. It's a pattern matching game. Your brain plays with itself, and it varies wildly from person to person. It is not a universal constant written into the fabric of reality. It's a biological hallucination, a useful fiction your brain creates to help you navigate the world. So when we talk about physics, when we talk about what time actually is in the universe, we have to throw your brain out the window. We have to stop talking about how it feels and start talking about what it actually is. In physics, we have to be operational. That means we don't sit around asking philosophical questions like, what is the essence of time, or what does time really mean? Because those are questions for philosophers who enjoy arguing over coffee and getting nowhere. We ask, how do we measure it? What are the operations we perform to detect it? And the answer is almost disappointingly simple, almost boring in its plainness. Time is just a way of ordering events. That's it. It's a labeling system, a filing cabinet for the universe. Imagine you have a deck of cards. You lay them out in a row on a table. You can say the jack comes before the queen and the king comes after the queen. The cards aren't moving, they're just sitting there. The table isn't flowing like a river. The order is simply a structural property of how the cards are arranged in space. Time is the table. Events are the cards. When we say time passes, we're just reading the cards from left to right, following the sequence we laid down. This brings us to the biggest mistake everyone makes, the deepest misconception about time. You think time is a container. You imagine the universe is a big empty box, a vast cosmic warehouse, and time is a clock on the wall of that box ticking away. Even if the box is completely empty, even if we removed every star, every planet, every atom, every particle of light, you think that clock would keep ticking. Tick, tick, tick. The seconds would keep piling up. Wrong, completely wrong. This is the Newtonian view of time, and it's dead. We killed it a century ago. Time is not a background stage. Time is not a container that holds events. Time is a measure of change. If absolutely nothing in the universe changes, if no atoms vibrate, if no light moves, if no energy shifts position or state, then time stops. It ceases to have any meaning whatsoever. You cannot define a second without a physical process to mark it. A swinging pendulum, a vibrating quartz crystal, a cesium atom oscillating between energy states. Time is not separate from the stuff in the universe. Time is a property of the stuff. Time is what the stuff does. This is where your intuition digs in its heels and fights back. You protest. You say, okay, but surely time acts on things. Surely time is an active force. Time makes me get older. Time causes the milk in my fridge to spoil. Time wears down mountains and rusts iron. No, it doesn't. This is a linguistic trap, a trick of grammar. Time is not an agent. Time doesn't have hands that reach out and do things. It doesn't reach into your refrigerator and sour your milk. Bacteria do that. Chemical reactions do that. The second law of thermodynamics, entropy, does that. Time is just the bookkeeping system we use to track the rate at which those reactions happen, the order in which those changes occur. Saying time did it is like saying inches built the house. Inches didn't build anything. Carpenters built it. Hammers and nails and human labor built it. Inches just tell you where the walls are, how tall the ceiling is. Inches are a measurement tool. Time is the ruler, not the worker. Time is the calendar, not the force that ages you. Let's push this ruler analogy further, because this is where things get really, really weird. If time is just a ruler we use to measure the distance between events, the separation between breakfast and lunch, what happens if the ruler itself is flexible? What if the ruler can stretch and compress like a rubber band? This isn't science fiction. This isn't speculation. This is measurable, documented fact. We see it every single day. We used to think that a second was a second anywhere in the universe. If you had a clock on Earth and an identical clock on Mars and another on some distant star, they would all tick-tock in perfect unison. Synchronized, universal. It feels obvious. It feels right, like it must be true, and it's completely, utterly false. The rate at which clocks tick depends on where they are in space and how fast they're moving through space. This is not a mechanical failure of the clock. This is not a design flaw. It is a fundamental feature of reality. Imagine you're driving a car across a giant flat sheet of paper that stretches in all directions. You can drive north, you can drive east. If you drive purely north, you're making maximum progress in the northwards. Direction every second. You're covering as much northward distance as possible. But if you turn the steering wheel and start driving northeast, you're sharing your speed between two directions. You're moving a bit north and a bit east. And here's the key. You aren't going north as fast as you were before because you diverted some of that motion to the east. Your total speed is the same, but it's split between two directions. Now replace north with time and east with space. This is the essence of relativity, stripped down to its core. You are always moving through the universe at a constant speed, always. But that motion is shared, divided between space and time. If you sit perfectly still in your chair right now, if you're not moving through space at all, you're dedicating all your motion to moving through time. You're traveling into the future at maximum speed, 1 second per second, if you want to use that phrase. But the moment you stand up and walk across the room, the moment you get in a car and drive or board a rocket and fly, you're diverting some of that motion into space. You're moving through space, which means you mathematically must move slower through time. Your clock slows down. Your aging slows down. Your heartbeat stretches out. You aren't breaking the machine. You're not doing anything wrong. You're just changing direction on the map of space-time. If you could somehow move at the speed of light, which is the maximum speed limit of the universe, the cosmic speed limit, you would be using 100% of your motion budget for space. You would have zero motion left over for time. For a photon of light racing through the void, time does not pass. It is born from some distant star and absorbed by your retina in the same instant from its own perspective. The entire journey is instantaneous. The universe is frozen. Now, you might be thinking, well, I don't feel my watch slowing down when I run to catch the bus. I don't notice time getting weird when I drive to work. Of course you don't. You're too slow. You're a biological snail crawling across the landscape. The effects are absolutely tiny at human speeds, microscopic, but they're real. They're there. We have to program satellites with this math. GPS satellites orbiting overhead are moving fast relative to you on the ground. And because they're moving fast, their time is ticking at a different rate than your time. We literally have to adjust their clocks to compensate for relativity. If we didn't account for this, if we ignored the time dilation, your GPS would be off by miles within a single day. Your maps would be useless. There's another aspect of time that tricks us, another layer of illusion, and it comes back to that counting problem we started with, the idea of pattern recognition. We perceive time as having a direction, an arrow pointing from past to future. The past is fixed, solid, unchangeable. The future is open, uncertain, full of possibilities. You can remember what you had for breakfast this morning, but you can't remember what you'll have for dinner tomorrow night. Why? If physics equations work forwards and backwards, and most of them do, why can't we remember the future? Why is there an asymmetry? If you film a planet orbiting a star and play the footage backward, it looks perfectly fine. It still obeys all the laws of gravity. The equations are happy. But if you film an egg falling off a counter and smashing on the floor, and then play that footage backward, everyone immediately knows it's fake. The yellow yolk doesn't spontaneously leap off the floor, gather itself into a perfect sphere, and seal itself inside a pristine white shell. That doesn't happen. That violates something deep in our gut sense of how the world works. Here's the secret, the key to the whole mystery. This isn't about time itself. It's about probability. It's about disorder, about the number of ways things can be arranged. It is much, much easier to break an egg than to build one. There are a billion different ways for an egg to be broken. Yolk scattered here, white splattered there, shell cracked into 3 pieces, shell shattered into 1,000 pieces. But there is only one very specific arrangement where the egg is whole, where all the molecules are perfectly organized into that fragile structure. So, as things move and bump and interact in the universe, they naturally stumble from the organized state, which has few possible arrangements, to the disorganized state, which has many possible arrangements. It's not a law that forces them, it's just overwhelming probability. We call this entropy, and this rising tide of disorder is the only reason you feel an arrow of time. You're watching the universe shuffle the deck of cards. You started with a perfectly ordered deck, all the suits lined up, and every second that ticks by is just the universe shuffling it a bit more, randomizing it, mixing it up. You can't unshuffle the deck just by wishing for it. You can't reassemble the egg by running the film backward. This means that your sensation of time flowing, your feeling that time has a direction, is actually just your brain registering the increase of disorder, the spread of entropy in the universe around you. You're a disorder detector, a chaos meter, and when you distinguish the past from the future, you're really just distinguishing less messy from more messy, lower entropy from higher entropy. If the universe were in a state of maximum disorder, maximum entropy, where everything was evenly spread out and nothing interesting was happening anymore, where all the energy had dissipated into a thin, lukewarm soup, your brain wouldn't be able to tell the past from the future. There would be no eggs to break. There would be no memories to form, because memory formation requires organized structures. In a thermal equilibrium universe, a dead universe, the arrow of time vanishes. Time becomes meaningless again. So let's go back to those people counting in their heads, the ones seeing the tape measure versus the ones hearing the internal voice. They're both struggling to impose a rigid, linear structure on a universe that is actually much more flexible, much more strange than either system can capture. We build these mental models, these counting machines, because we need to survive. We need to know when the predator is coming, when the fruit will ripen, when winter will arrive. We evolved to track duration, to estimate intervals. But we did not evolve to understand the dimension of time. Our brains are efficient, not accurate. We focus on the now, the present moment, because that's where we live, where we eat and breathe and reproduce. But in physics, now is a very slippery, almost meaningless concept. If you and I are standing next to each other in the same room, our now is effectively the same. We agree on what is happening right now. But if you're on a planet a million light years away from me and you start walking away from me at a steady pace, your definition of now, your slice through the universe of what is happening at this instant, cuts through space-time at a different angle than mine. What you consider to be happening right now in this moment might be in my future. What I consider to be happening right now might be in your past. The angle of the slice depends on your motion. There is no universal now that covers the whole universe like a blanket, no cosmic present moment that everyone shares. The universe is not a film strip running through a projector one frame at a time. The universe is a block, a four-dimensional loaf of bread. Space provides 3 dimensions. Time provides the 4th, and how you slice that loaf, what angle you cut it at, depends on how fast you're moving and in what direction. This is extraordinarily hard to grasp. It feels wrong. It feels like I'm lying to you, like I'm telling you that up is down or left is right. But that's because you're trying to translate the high-level language of the universe, the language of mathematics and geometry, into the low-level language of your biology, the language of feelings and intuitions. You're trying to count socks when you should be measuring light beams. You're trying to hear a voice when you should be seeing a geometric structure. When you try to force the universe to fit your intuition, When you insist that time must flow like a river because that's what it feels like, you get confusion, you get apparent paradoxes. Things seem impossible, but when you let go of what you think time is, when you stop trying to count it like a pile of laundry and start measuring it like a dimension of space, like a direction you can move in, suddenly the equations work. Suddenly the contradictions dissolve. Suddenly the universe makes sense. But we're not done. We're not even close to done. Because even if we accept that time is a dimension, and even if we accept that it stretches and squashes depending on speed and gravity, there's a much deeper question lurking at the bottom of the well. We talked about measuring time. We talked about the arrow of disorder, the rise of entropy, but we haven't talked about the beginning, the origin point. If time is a measure of change, what happens when you run the movie backward all the way to the first frame? If the universe is expanding, spreading out, cooling down, and we wind the film back, it gets smaller and smaller, hotter and hotter, denser and denser. Eventually, if you keep going, you hit a point where the laws of physics themselves start to melt, where the equations break down and stop making sense. You see, all our clocks, all our measuring devices, our atoms, our planets, our light beams, they exist inside the universe. They're made of the universe. But if the universe itself was born in a moment we call the Big Bang, if there was a beginning, does it even make sense to ask what happened before that? This is the ultimate test of your new definition of time. If time is just a way of ordering events inside the universe, if it's just a labeling system for changes that happen to physical stuff, then asking what happened before the universe existed might be as nonsensical as asking what is north of the North Pole. It sounds like a valid question. Grammatically, it's a proper sentence, but geometrically, spatially, it's gibberish. There is no north of the North Pole. The question doesn't have an answer because the concept doesn't apply. There may be no time before time began. No before the beginning. And yet, we still have that nagging feeling, that internal counter, that voice in our head counting 1, 2, 3. We desperately want the universe to have a backstory. We want a timeline that stretches back forever into an infinite past. It's hard, maybe impossible, for us to accept that the tape measure might just start somewhere, that the counting machine had an on switch, that there was a first moment. This creates a fundamental friction between our psychology and our cosmology. We are finite beings with finite brains, trying to comprehend the infinite, trying to grasp the universe as a whole, using tools made of meat and electricity. It's honestly a wonder we understand anything at all. Consider the patterns again, the different ways of counting. The person who sees the tape measure in their head can count time while reading a book because they're using different neural circuits. Visual versus verbal. Physics is the same. Classical mechanics, Newton's laws, that was the verbal counting. It worked perfectly fine for everyday stuff, for cannonballs and falling apples. Relativity is the visual tape measure. It allows us to process complex patterns, situations involving high speeds and strong gravity that the old way couldn't handle at all. We're constantly upgrading our mental software to match the hardware of reality, and the upgrade process is painful. It's disorienting. It requires discarding ideas we love, comfortable notions like the river of time, like the universal now. But here's the beautiful part, the redemptive part. Even though your intuition is wrong, even though your internal clock is a biological pack cobbled together by evolution, and even though time is actually a flexible, relative, bendy dimension rather than a strict universal metronome, it still works for you in your daily life. You can still boil an egg. You can still show up to meet a friend for coffee at 2 p.m. You can plan a vacation, catch a flight, celebrate a birthday. The weirdness of relativity, the strangeness of space-time is hidden under the hood, buried in the fine print. You don't need to understand the internal combustion engine to drive a car. And you don't need to understand Lorentz transformations and space-time metrics to live your life. But isn't it better to know? Isn't it better to know that the engine is there, that the machinery exists? This brings us back to that strange experiment with the counting, with the voice versus the image. Remember the profound difference between the person who hears numbers and the person who sees them. This is not just a cute party trick or a quirk of neuroscience. It reveals a terrifying gap in how we understand the now universe, a chasm in communication. When two people talk to each other about something complex, something abstract like time or space or relativity or love or consciousness, they think they're speaking the same language. They nod along. They agree. They say, yes, I understand what you mean. But what's really happening under the surface? You're running a massive invisible translation scheme. You take the words I say, the sentences I construct, and you convert them into your private internal imagery, your personal mental representation, which might be completely, utterly different from mine. I say 1 minute and I see a clock face with hands sweeping around. You hear a voice in your head saying, 60 seconds. We arrive at the same practical answer, the same number. So we think, we agree, we think we understand each other, but the machinery inside, the actual computational process, is totally alien, completely different. This matters enormously for physics, because it exposes the fragility, the brittleness of common sense. Common sense is just the collection of prejudices, of unexamined assumptions you acquired by age 18. It's built on your specific internal imagery, your particular mental models. If your mental image of time is a tape with numbers clicking past, you'll struggle to understand how time can bend, how it can slow down or speed up. The image resists. If your mental image is a voice steadily counting, you'll struggle to understand how time can be spatial, how it can be a dimension like left and right. The voice wants to keep counting at a steady pace. When we try to teach you about the quantum vacuum, or the curvature of space-time, or the block universe, we aren't just giving you new facts to memorize. We're asking you to delete your operating system. We're asking you to throw away the tape measure, silence the counting voice, and install something completely new. And that's why it feels so impossibly hard. That's why your brain rejects it, fights against it. You aren't just learning new information. You're translating against the grain of your own biology, rebuilding the foundations while standing on them. You're asking your counting machine to count in a way that was never designed to count.